Welcome to American Medicine Today. I'm Kimberly Bonatti alongside Ethan Euchre and world-renowned orthopedic surgeon Dr. Alfred Bonatti. So a new collection of essays is offering informed predictions for how the use of Crispr today will actually affect life in the future and how technology should be regulated moving forward. Joining us to discuss is Neal Baer, MD, public health advocate and award-winning executive producer for shows like Law & Order, Special Victims Unit, and the forthcoming book, The Promise and Peril of Crispr. Thank you for joining us, Dr. Baer.
Thank you for having me.
So we've been covering this CRISPR technology for several years now. Can you explain what it is for those who might not really be familiar?
It's a really brilliant technique that uses enzymes to home in on a section of DNA, cut it out, and paste in new DNA so that if you have, let's say, a mutation, you can cut out the DNA that is misinformed in its letters from DNA and put in the correct DNA.
I think we've actually talked about it in the sense that it's almost like, choosing your meal off of a fast food menu. Is that kind of what CRISPR does?
Well, it goes in and it takes out something that's a bad section of DNA that's causing a disease and puts in the new DNA.
What are some of the challenges that are posed by CRISPR as dual-use technology?
I think dual-use technology is a great way of thinking about CRISPR because it's the good and the potentially bad. So that's the promise and that's the peril. So the good side is that we can cure now a disease like sickle cell anemia, which is terrible. It affects 100,000 Black Americans in the United States alone. We can turn on a good gene now and cut out or turn off the bad gene. Now, that's the promise. The peril is making worse viruses or bacteria by manipulating and cutting out genes and making potentially a virus more transmissible, let's say. It also could be used in the future. We can't do it now to, let's say, enhance people so that, if you wanted to have, more musculature or be able to sleep less.
If you cut one of the bad genes there and you need to bring another one, how you select the one that you bring?
We know the kind of gene sequence that causes, let's say, sickle cell disease or Huntington's disease. So we could then put the proper sequence in by cutting out the bad sequence, and we know what the proper sequence is. And then there are companies that make DNA sequences so that they can be purchased. And this is another issue of the dual-use technology, which is there's very little control over who can buy these sequences. And so potentially people could be making all kinds of things. They have to have the expertise, but we don't have any laws, both in the United States or internationally, that oversees and controls who gets access to these sequences that could be used to make, for instance, polio or horsepox. Like that's something like smallpox. This has actually been done by researchers. Horsepox was made in Canada, for instance, by putting different DNA sequences together that can be purchased by companies that make these sequences.
One of the genes, for example, that is very much talked all the time is the gene of longevity. Is that something that we can expand the life, or how we do it? We need to do it when the person is born, or we need to do it after, or we need to do it any time?
So there are many, many factors depending on if you inherit the APOE gene, which can contribute to your chances of getting Alzheimer's, let's say. So you'd have to address all the different genes that can cause certain kinds of atherosclerosis or Alzheimer's. And so there isn't one gene that can do that. So CRISPR is really good at dealing with one gene like sickle cell disease, beta thalassemia. We haven't been able to address Huntington's disease yet, but we're learning how to do these things. And we can definitely cure people with certain diseases and some rare liver diseases right now. There are children, for instance, who have a genetic disease or syndrome where they don't feel pain. And so can you imagine? I mean, it's kind of, that's the dual use technology. It's kind of terrifying if we start to, enhance soldiers so they don't feel pain when they're out in the field. It's something to think about now because we're moving forward. It's like AI. It's like we don't know where AI is going, but we might want to put some brakes on, or at least some oversight before it gets out of hand.
Elon Musk said something that he predicts between a 10 and 20% chance of AI causing catastrophic events around the globe.
Scientists move forward and then the ethics follow. So in other words, in 2015, there was a lot of talk about CRISPR and saying we should have societal consensus. After Dr. He in China used CRISPR to change the gene of twins, those twins were made so that they were resistant to HIV, and it caused an uproar around the world. Dr. He took the egg and he changed the receptor in that embryo. Those babies were born. So that is changing evolution. When we treat sickle cell disease, we are not giving the person with sickle cell disease the ability to not pass on that sickle cell gene. That's called somatic gene editing. That is another dual use technology issue. Somatic, meaning treating diseases, or germline, meaning changing humans.
That's incredible technology. Thank you so much for sharing your insight with us, Neal Baer, MD. Thank you for being on the program.
Thank you for having me.
We're going to take a quick break. We'll be right back with more. You're watching American Medicine Today.